Okay, so we talked about the mean, and we said we'll use either x bar or mu, depending on whether it's from the sample or if it's from the population. Those are just the symbols. And then we have the definition is sigma x sub I over, and then we either write capital N or small n here, depending again on if it's the sample or the population of the sample. Okay, so let's take some numbers like 2, 4, 6. Well, let's say 8 and 10. Okay, so we have 5 numbers there, and I think it's pretty clear that the mean is 6. It's right in the middle. If you add them all up and divide by 5, you're going to get 6. So that's the mean. And we saw that if you change one of the numbers, for example, sometimes you're recording numbers and for example, you add an extra 0 there. So if that happened by mistake, now we have these numbers, and we call this an outlier. Oops, I can't do that very well. We call this an outlier, and it's going to change the mean by a lot, right? If we take 2 plus 4 plus 6 plus 8, so that's what, 6, 12, 20, and then plus 100 equals 120. And if we take 120 divided by 5, we get a much different number than 6. In fact, we get what? 24, right? 24. Okay, so it went up by a factor of 4, actually. So, therefore, we can say that the mean is sensitive to these big numbers. We called it an outlier. So we can say the mean is sensitive to that, meaning if you have an outlier, it's going to really change things. Okay, now let's talk about it. But rather, the mean is called a measure of the center. And that's pretty clear. It's supposed to measure the center of the numbers. Sorry. 2, 4, 6, 8, 10. It's supposed to measure the center of that, and the mean is 6. That's kind of the center. Okay, but we have other measures of the center as well, and another one is called the median. And the median is obtained in a different way. The median, what you do is if you have 5 numbers, let's change them. Let's say we have 1, 2, 9, 20, and 4. Okay, first of all, to get the median, you have to rearrange them in order. So we'd have to write them 1, 2, 4, 9, 20. So that's what you have to do first. And then what you do is you choose the number which is in the middle number. So here there are 5 numbers, 1, 2, 3, 4, 5. So the middle number is going to be the third number, which is here. So that will be defined to be the median. So the median is the middle number, and it's 4. Now, if you have an even number of numbers, here we had 5 numbers, which is an odd number of numbers. So if it's an even number of numbers, we do it slightly differently. But right now, let's just say that it's the middle number, and it's equal to, in this case, 4. Now the mean, what is the mean? If we wanted to calculate it, might not come out very well, but we would get, we get 3 and 4, 7, and 16 and 20 is 36. So it doesn't work out that well. It's 36 over 5, which is about 7.2, right? I think that's 7.2. Whatever it is, it's not the same as 4, right? So the mean and the median are not the same thing. Now, 7.2, we could say, is the center of this set of numbers, or we could say that 4 is the center. So the word center is not exactly well defined or clearly defined. So we could say that it's 4, we could say that it's 7.2. However, the word mean is clearly defined. We know exactly how to compute it. We can't say that the mean is 4. We can only say that the mean is 7.2. It's clearly defined. Okay, so the mean is clearly defined, and the median is also clearly defined, at least when we have an odd number of elements in the set. Now what happens to the mean if we get an outlier? Like suppose this 20 becomes 200. The median, what did I say? What happens to the median if we get an outlier? So the mean is obviously going to change a lot, right? When we change that 20 to 200 and then calculate the mean of that, it's going to be much bigger. But what happens to the median? Does anything happen? And the answer is no. The median doesn't change at all. So we can say that in general, the median is not sensitive to outliers. So that whereas the mean is sensitive to outliers, the median is not. Okay, so that's the idea of the median, and it's also measuring the center, and sometimes we might prefer to use the median. And I believe that in when countries report their distribution of incomes, usually you say, okay, how many people make $50,000? How many people make $60,000? How many people make $70,000? And so on. So you have this kind of curve. Now this kind of curve tends to be, doesn't have to be, but it tends to be skewed to the right. We talked about skewed to the right, and it tends to be skewed to the right, which means that there are going to be a few people that are very rich. Now in different countries it'll look different, but this often happens that it's skewed to the right. Now it seems like in economics they usually don't report the mean income. They usually don't give that number. They usually report the median. And I guess the reason is, I don't know the reason, but one thing we can say is that the median is not going to be sensitive to outliers. So if somebody earns a whole lot of money out here, the median may not change at all. So the median is not exactly sensitive to the high income earners. So I don't know why they would want to report that. But, well, I guess they're trying to, I guess the answer is they're trying to find some number which is representative of the whole population. So the fact that one person earns a whole lot of money would skew the mean, but it won't skew the median. And if you want to talk about what typically people earn, maybe you don't want to include that super high number as being a big factor.